Isatap is an IPv6 transition mechanism meant to transmit IPv6 packets between dual-stack nodes on top of an IPv4 network. Unlike 6/4, Isatap uses IPv4 as a virtual non-broadcast multiple-access network data link layer, so that it does not require the underlying IPv4 network infrastructure to support multicast. How Isatap works: Isatap defines a method for generating a link local IPv6 address from an IPv4 address, and a mechanism to perform neighbor discovery on top of IPv4. Link local address generation equals any host wishing to participate in Isatap over a given IPv4 network can set up a virtual IPv6 network interface. The link local address is determined by prepending FE802005 a euro for globally unique addresses, or FE800005 a euro for private addresses, in front of the 32 bits of the host's IPv4 address. For example, the global IPv4 address 192.0.2.143 would use FE802005 192.0.2.143 as its link local IPv6 address. The shortened notation would be FE8205 CO100028F. Neighbor discovery equals, because Isatap uses IPv4 as a non-multicast broadcast-capable link layer, ICMPv6 neighbor discovery cannot be done in the usual manner. That is why Isatap is a bit more complex than 6/4. From the viewpoint of the IPv6 packet, the link layer is the IPv4 packet. As the link layer address, the IPv4 address, is contained in the lower order 32 bits of the IPv6 address, neighbor discovery is not really needed. However, the lack of multicast support prevents the use of automatic router discovery. Therefore, Isatap hosts must be configured with a potential routers list. Each of these routers is infrequently probed by an ICMPv6 router discovery message, to determine which of them are functioning, and to perform unicast-only auto-configuration. In practice, implementations build their PRL by querying the DNS, for example by looking up isatap.example.com if the local domain is example.com. The local domain is typically obtained via DHCP or statically configured. Criticisms of Isatap: Isatap typically builds its PRL by consulting the DNS. Hence, in the OSI model it is a lower layer protocol that relies on a higher layer. A circularity is avoided by relying on an IPv4 DNS server, which does not rely on IPv6 routing being established. However, this is a violation of network design principles, and feels brittle to some network specialists. Isatap carries the same security risks as 6/4. The IPv4 virtual link must be delimited carefully at the network edge, so that external IPv4 hosts cannot pretend to be part of the Isatap link. That is normally done by ensuring that Proto41 cannot pass through the firewall. Implementations of Isatap: Isatap is implemented in Microsoft Windows XP, Windows Vista, Windows 7, Windows 8, Windows Server 2008, Windows Server 2012, Windows Mobile, Linux, and in Cisco IOSS and iOS XE Release 2.1. Due to a patent claim, early in-kernel implementations were withdrawn from both KAME and USAGI. However, the IETF IPA disclosure search engine reports that the would-be infringing patent a unregistered trademark S holder requires no license from implementers. Isatap support has been supported in Linux since kernel version 2.6.25. The tool Isatap provides a user space helper. For prior kernels, the open-source project Moredo provided an incomplete userland Isatap implementation, which was removed in version 1.1.6. References: Other F. Templin, T. Gleason, D. Thaler Intra-Site Automatic Tunnel Addressing Protocol or FC 5214, March 2008. External links: http://www.isatap.org/